The company was formed by two riders. Our bikes are designed by riders. The majority of the bike is actually imported. The gears, the transmission system is imported. The heart of the bike, the frame, is the part that we make. A lot of the time the development actually starts from, for example, a new component. One of the transmission companies might come to us and say we're designing a certain part. So we look at how we can use that, what it will bring to our frames. Geometry is the key to all design. The angles of the bike, that's the seat tube and the head tube, where the front wheel fits, where the back wheel fits, and where the rider sits in between them. That's the key to how the rider feels, what they actually experience. What we've got here is the very first orange clockwork. It's the first model we made, and you'll find that on this bike you'll notice you've got very small tubes. It's made from steel. The frame's designed in one piece. It's a double diamond frame. It's got no suspension either at the front or the back. Current 2008 Orange 5. It's actually made from aluminium. If you notice now, we've got much bigger tubes, got a big box construction. It's a full suspension design, which means it has suspension to absorb the shocks. That's both front and back. The frame is now in two pieces. The rear triangle can actually move. It's connected by a shock absorber, but it can actually move and absorb all of the bumps in the road. This is our top-of-the-range downhill bike. These are race competition bikes, so the rider needs to be able to tune the geometry of the bike, and by using the shuttle and the adjustments on this slider, they can actually lower the whole bike down, so the whole bike can be sat down. All of this moves forward or back, depending on how they want the bike to feel.
So this is the sheet metal work factory. This is where we turn flat sheets of aluminium into mountain bike frames. This is a piece of 6061 aerospace grade aluminium. Obviously it's very, very lightweight. It's also very durable, very strong, but also it has a key element of flex in the material as well, so it makes it less brittle than something such as steel. So what we do is we take the blank of aluminium, we feed it into a machine like this. What this will basically do is cut any shape that you want out of a flat sheet. What you can see going on behind me is basically we're cutting some down tubes for the bikes. We transfer AutoCAD drawings into an actual machining software package that basically tells the machine exactly where to use each punch, because it'll use several different punches in a program, and where exactly on the sheet to make each hit. So basically we've got our first component part, which is a down tube. So the next process is to turn this into a three-dimensional shape. For that we need one of these machines. With this particular machine you've got 80 tons of bending pressure, but you have various different tools that you can put into the machine, what we call dies and V's, to form different radius bends. And essentially at the given points that are programmed into the machine, it comes down and it presses the die into the V, and it forms the material into the shapes that is required. There's several different types of tube that we use. We cut it, we miter it, and then we belt notch it. What that allows us to do is it allows us to get a good clean weld between two pieces of tube.
Once the frame comes down from the frame building plant into the assembly area, it will then be cleaned, ready for paint. We use an acid etch, which actually cleans all of the dirt off the frame and also makes it a key for the paint. The paint won't stick to the aluminium, it's too smooth, so we have to actually make it a slightly rougher surface. The paint we use is a tough powder coat. It's not wet, it's not liquid. It's applied electrostatically and it gets heated, sits in the oven at about 180 degrees centigrade, and at that point becomes liquid and then sets hard. Every bike is assembled by hand. One of the big advantages we have with having our manufacturing here is that we can make each bike individual. We have about 8 frame designs. We offer about 25 models of bike based on those frame designs, but you then combine that with probably 4 sizes, I think about 20 colours, so the number of models, infinite. The future for us will continue to develop bikes. Riders push the boundaries all the time. We have to develop bikes that do that. We've got new development in full suspension. We're understanding more and more about how suspension works. New transmission systems. A bike becomes more and more like a motorcycle rather than the original road bike. And provided we understand how that works and what people will use it for, there'll always be a future.
I'm Mike Brook and I'm the Production Improvements Manager for Polestar Sheffield, one of Europe's largest commercial and magazine printers. And I'm responsible for ensuring that we produce 13 to 14 million magazines a week. We've tried to set up the factory and the production process to ensure the most efficient manufacturing methods are used and the minimal amount of waste is produced.
The customers send us their digital data and they are essentially saying to us, this is what we want to print. It's our responsibility to print that exactly as the customers give it to us in terms of content and importantly in terms of colour. When we print with 4 individual colours. We print with a cyan ink, a magenta ink, a yellow ink and a key ink, which is a printer's term for black. When those colours are combined, we can replicate millions of different colours on the press. The key adds definition, it adds tone, it gives life to those colours. We're a Gravure printer, as opposed to web offset or letterpress. What Gravure means is we print on cylinders as opposed to plates. With any product, we need 8 cylinders. 1 cylinder for the yellow, 1 for the magenta, 1 for the cyan and 1 for the key on both sides of the paper. So a digital image is sent from the data room. What the engraver then does, it looks at the percentage values of that image and it engraves what we call a cell, which is essentially a hole into the cylinder. Those cells are there to hold ink. So the bigger the cell, the more ink it holds. The more ink it holds, the darker the colour, the darker the density when it transfers over to paper.
At the moment we're in our paper store. We've got a lot of reels in stock. They might all look the same once they're wrapped up, but underneath there's different finishes, matte finish, gloss finish, newsprint and different types, sizes and weights. The reel I'm stood next to is about 3.5 tonnes in weight, can be up to 3 metres wide and we can get a maximum of 20 kilometres of paper out of that. The first stage of the process is to get the reels onto the press. Each press can hold 2 reels at any time. The far reel is actually running into the press at the moment and this reel is waiting to go on. Now the process never stops, so once that reel gets to the end, this reel will start to turn round and will automatically splice on, so the machine never stops.
This here is the magenta cylinder. This is now press ready. Rotate the cylinder, you see there's an image all the way around it. 52 pages, which have all been separated out into the magenta channel only. This cylinder here will go into the press now. When it goes into the press, half of it will be sat in ink. As it rotates and comes out of the ink, it'll have ink covering the cylinder. A doctor blade then wipes ink off the surface of the cylinder, leaving it in the cells. This bit of paper here represents the web, which of course will stretch from one end of the cylinder to the other. When this is in the press, this bit of paper is put under pressure, so it's pressed against this cylinder. Ink's in the cells, and that ink under pressure transfers from the cylinder onto the paper. So that's running through, and as we can see, that magenta ink there is transferred over to the paper. The paper then moves as the cylinder rotates. This bit of paper then moves onto the blue unit, the blue ink's applied, and sits exactly over the top of the image already printed. This process repeats itself and repeats itself.
Once the paper goes through the other end of the press, it's cut from its large format down to its small format and then folded as it comes out at the end here to the finished section that you can see. One of the most crucial parts of our job is starting a new print run to get the machine up to speed, up to quality as quick as possible. What you'll see is the guys checking sections coming off the press. They'll be checking for register, they'll be checking for colour, they'll be going back to the press, making fine adjustments while the press gets up to speed. While that check's going on, those sections that haven't got the right quality will go into the bin, so they'll be dumped.
Register means that when the four colours overprint each other, that the yellow dot sits exactly on top of the red dot, which sits exactly on top of the cyan dot, which sits exactly on top of the key dot. We also have to take into account colour. We have a system here which allow for the printers to do a quick check, so making sure the four colours we print with are at the correct density.
Once the guys are happy with the quality, they'll flick a switch on the dump gate. The gates will come up and those sections will go through to be good copy. This is one of the finishing lines, and this is the machine where all the sections are put together to form the finished magazine. So a magazine might be made from several sections, and we can put up to 7 different sections into a magazine to make up a finished book. So as each section comes along the drum, they're basically put on top of each other. So we've seen the whole sort of process from start to finish now, from the data being produced to the cylinders being made, going onto the press, the printed section being cut, folded, wound onto disc, the disc being sent over to the stitching line, all the sections being put together to make the finished magazine that we see coming out at the end now. All that's left to do really now is to package that, to strap it, bundle it, put it onto a pallet and send it out on the vehicle.